My name is Joshua Bardwell. I'm an RF engineer with Connect 802, and today I'm going to show you how to configure per band SSIDs with the Ruckus Zone Director. In this video, I'll be going into some of the more detailed background aspects of this process. If you just want to go through the steps to get the job done, check out the walkthrough video, which is linked in the video description below. The steps involved in setting up per band SSIDs on a Ruckus Zone Director are a little unintuitive to some people at first. I know the first time I sat down to do it, I just said, oh, I'm sure I can figure this out. And it took me a little bit of time to work through the steps. It's not as simple as just ticking a box. The first thing you need to know is that the Ruckus system organizes the APs into AP groups. All APs go into the system default group by default, and you can set up other groups if you want to, but for many simple configurations, you'll simply have one group, the system default group, and that's where all APs will get their configuration. So let's go ahead and look at the options under the system default group. We can see here that the AP group defines the channelization for the APs, what channels they'll use, how wide the channels should be, the transmit power, and other such options like that. Those options can also be configured on a per AP basis, but the default configuration is to have all APs take their configuration from the system default group or whatever other group the APs happen to be in. The main feature that we're concerned with, though, is the default WLAN group. When you think about putting an AP into 2.4 or 5 gigahertz, you often intuitively think about that on an AP level, but Ruckus puts that decision at the WLAN level. So a given WLAN will be assigned to 2.4, 5 gig, or both, and then APs will broadcast that WLAN in the assigned bands. This actually makes sense because you may have some WLANs broadcasting in one band, some in another band, and some in both bands, and you wouldn't want to restrict any single AP to only being active in one band or the other. APs are grouped into AP groups, and WLANs are grouped into WLAN groups. And you can see here we've created the 2.4 gigahertz only and the 5 gigahertz only WLAN group, but we could really make any kind of divisions that we want. Many sites, though, are not going to have a huge number of WLANs. In fact, from the perspective of network performance, it makes sense to minimize the number of WLANs. So, for example, you might have a guest WLAN, an employee WLAN, maybe a voice over IP WLAN, maybe one other WLAN for infrastructure or something like that. Maybe 3 or 4 WLANs is what a typical corporate site would have. And even a very large site might not have a huge number of different WLANs. They might have the same WLAN pushed out over all of their sites. So it's common to see AP groups and to have a lot of AP groups. Like, for example, if you have a bunch of different physical locations, you could group the APs by physical location. But it's less common to see a huge number of different WLAN groups. And the situation we're describing here, where you have 2.4 and 5 gig broken out, is one of the more common reasons why people might use WLAN groups to group WLANs. If we go ahead in and edit the WLAN group, you can see that the configuration is not that complicated. We can choose which SSIDs are going to go into this WLAN group, and optionally we can override the VLAN that is being assigned to those SSIDs. So you can see that here, since we've decided to use this WLAN group for 2.4 gig only WLANs, we've picked the WLANs we want broadcasting in 2.4 gig. If we go back now and look at the AP group config, we can see that the AP group allows us to describe which WLAN group the two radios in the AP will get, the 2.4 and the 5 gig radio. By default, both radios are assigned to the same WLAN group, which is the default WLAN group. So basically, you just define your WLANs. They go in the default WLAN group. The APs go in the default AP group. They take their WLANs from the default WLAN group, and you basically are just defining all your WLANs in one big group. It keeps it really simple if you just got the system and you don't want to delve into this additional detail. But what we do in this situation is we set the 2.4 gig radio to only get its WLANs from the 2.4 gig group, and the 5 gig radio to get its WLANs from the 5 gig group. And then by assigning WLANs to those groups, we cause the radios to only broadcast those WLANs. It's a little bit of a roundabout way to do it, but it gives you a lot of flexibility to define more complicated situations if that's what you need to do. In this case, we've got a situation where we want to do something just a little bit complicated, and the tools that we're being given are a little bit more sophisticated than we maybe require, and that's why there's a little bit of a roundabout way of doing it. Okay, well, I hope that's been helpful. I hope it's provided some background into the way that the Ruckus Zone Director organizes its access point and WLAN configuration. If you want to follow the exact steps to configure per-band SSIDs on your system, look for the quick and to the point video linked below in the video description. I hope this video has been helpful to you. Whatever your wireless needs, from indoor office Wi-Fi to outdoor 60 gigahertz point-to-point microwave, 400 megahertz spectrum analysis services, wireless network design, survey of existing buildings, troubleshooting of wireless networks that are not working up to spec, whatever it is you need related to wireless, ConnectData2 is your resource for commercial wireless data networking. With 20 years in the wireless networking business and over 1 billion square feet of area design, chances are that whatever your wireless needs, not only can we do it, but we have done it. Please give us a call or an email today.